very good day to all. So in today's lecture series, we'll be discussing about gas tungsten arc welding. So the gas tungsten arc welding is an extended application of conventional arc welding process. We have already discussed about the arc welding process. So it's an extended application of the arc welding process. So in the conventional arc welding, everything is manually done, be the feeding of filler metal or the movement of operator, but this gas junction arc welding can be automated. So it has capabilities to automate the welding process. So this is a short introduction to the gas junction arc welding. How the process can be automated, we can see in the subsequent slides. So we can say gas junction arc welding as an industry-based application of conventional arc welding process. So gas junction arc welding process. Here the important thing to note here is the electrode used here is a tungsten electrode. So I'll show the image. So as you can see here, the welder is using an electrode. So the electrode here used is tungsten. So tungsten has a very high melting point around 3200 degrees Celsius. The welding temperature generated is around 1500 to 2000 degrees Celsius. So what happens here is the electrode will not melt during the welding process. Since the electrode will not be melted, it will not be consumed. So hence it is called as a non-consumable electrode. Whereas to take the arc welding process, the electrode will be utilized during the welding process. Hence it is called as a consumable electrode. But here the electrode used is a non-consumable electrode. That's one major difference between the arc welding and the gas tungsten arc welding. So another major difference between the arc welding and the gas tungsten arc welding is that in the conventional arc welding, we'll be using flux, which will be coated on the surface of the electrode. So flux provides protection from oxidation. So flux prevents oxidation as well as removes impurity from the welded area. But if you go on an industrial scale, the flux cannot provide when you are say when you are welding thicker plates, the flux which is coated on the electrode will not be sufficient to provide shielding to prevent oxidation. So in such cases, here what they are using is they are using a shielding gas. Shielding gas will be supplied around the electrode itself. So as you can see in the image, the shielding gas will be provided around the electrode via the chamber. So this shielding gas, what it does is it forms a layer around the welding region so that oxygen cannot enter into the welding region and prevent oxidation. That's a major difference between another major difference between conventional welding and conventional arc welding and gas tungsten arc welding. So far we have discussed two major differences. One is non-consumable electrode, tungsten, which is non-consumable electrode is used, and also here shielding gas is utilized instead of flux. So a doubt may arise how the gap between two workpieces may be filled here. Like gas welding, where we'll be using a filler rod, external filler rod, here also external filler rod will be utilized. So that filler rod will be wire fed filler rod. So it will be in the form of wire and it will be fed through the wire feeder mechanism. The wire feeder mechanism will provide the filler rod for the welding process. So this ensures continuous supply of filler rod. As I said in the starting itself, automation can be implemented here in the delivery of filler rod as well as the movement of welding torch. So robot-based welding, you would have seen robot-based welding videos. So such videos are done using this tungsten arc welding as well as another form of welding is called as gas metal arc welding. So we'll see in the next slide, next video. Both these processes can be automated using robots. Most of the industrial robot welding processes are either gas tungsten arc welding or gas metal arc welding. Other than that, laser welding is also done. That's the process of this gas tungsten arc welding. So coming back to the working principle, it is same as that of the arc welding. Here there will be a gap maintained between the electrode and the workpiece. So that gap provides a electric arc. That arc is used to melt the welding workpieces, and they will be joined together. External supply of filler rod will also be provided. So that's a major function of this uh, working principle of this gas tungsten arc welding process. So applications, wide variety of thickness of plates can be welded using this gas tungsten arc welding, and also it can be used to weld wide variety of alloy steel, stainless steel, heat resistant alloy. Anything can be welded using this gas tungsten arc welding process. So this is recommended for thin as well as thick plates. So a small assessment for you. Which of the following process uses a non-consumable electrode? So you would have known from the lecture gas tungsten arc welding. So other process uses consumable electrode. This uses a non-consumable electrode. Reason because tungsten is used as an electrode, which will not melt during the welding process because it has a very high melting point. Gas tungsten arc welding next process. Gas tungsten arc welding, the following polarity is used. So here alternating current with high frequency is used. So I hope you understood today's topic. So to give a quick recap, today we discussed about the gas tungsten arc welding, which is an extended application of gas arc welding. Sorry, it's an extended application of arc welding. Here, non-consumable electrode is used, and also shielding gas is used instead of flux. Shielding gas provides protection from oxidation. So I hope you understood today's topic. We'll see you in another lecture. Thank you.